Good morning, ladies and gentlemen. My name is PK Banerjee, and I'm the General Manager of DataCore Healthcare. Today, we will be embarking on an intriguing journey into the realm of generative AI, a revolutionary branch of artificial intelligence, and the promise it holds for the healthcare industry. We start our journey with an introduction to artificial intelligence and generative AI, with some historical perspective and the current state of affairs. We take a peek at the two core structures which are the driving forces behind its powerful capabilities. Moving beyond the technicalities, we contrast generative AI with traditional AI, spotlighting the features that set it apart and position it as a catalyst for innovation. We then shift focus to the potential enhancements and efficiencies generative AI can bring to the healthcare industry, specifically with respect to patient engagement and operational efficiencies. However, as with any technological marvel, there are risks, and we must learn how to use this tool in a responsible manner. We will talk about some of these risks and what to look out for. Finally, we address the crucial question: what can generative AI do for you? Offering insights into how this technology aligns with your business and business objectives and opens new horizons for advancement. Join us in this exploration, ask questions, and let us together unlock the promise of generative AI in transforming healthcare. You must be aware by now that generative AI has taken the industry by storm. But before we get going with generative AI, let's pause for a moment and consider what AI, or artificial intelligence, is. Intelligence can be defined as the ability to solve complex problems and make decisions with outcomes benefiting the actor. We humans have acquired this ability as a result of millions of years of evolution. But what about machines? Philosophers have throughout the ages pondered on the question: can machines think? Or, in other words, the possibility of machines acquiring this rare capability that we call intelligence. This is what is referred to as artificial intelligence, or AI, as opposed to the natural intelligence that we possess. Which brings us to Alan Turing and the Turing test. Alan Turing was an English mathematician who is widely considered to be the father of theoretical computer science and artificial intelligence. Many of you may have seen the biographical thriller movie Imitation Game, which depicts the genius of Alan Turing and how he deciphered German Enigma messages during World War II. But what you may not know, Imitation Game was actually the name of a test, commonly known as a Turing test. The test was devised to gauge a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. Any machine that passes the Turing test can be said to possess artificial intelligence. But I digress. Let's get back to today's topic. AI has seen a lot of activity in the past decade and comes in many different flavors. One of them is generative AI. Generative AI, often referred to as Gen AI, represents the newest frontier in AI technology. It is the creative powerhouse of AI, capable of autonomous generation of valuable content, whether it is text, images, or any other types of media. It's like having an AI helper at your disposal. Machine learning, as you all know, is at the core of AI. Different machine learning models are used depending on the domain, the characteristics of the data set being used, and the desired outcome. Gen AI currently uses a generative pre-trained transformer model, or in short, a GPT, And that's where the name ChatGPT comes from. Here is a brief history of generative AI. Artificial intelligence started as an academic discipline about 70 years ago, back in the mid 1950s. While foundations of AI were laid at that time, it was soon realized that running these algorithms efficiently without would require tremendous processing power and memory, which was not available at that time. Consequently, AI entered a period of hibernation, which lasted quite a few decades. With growth of computing power and falling costs of memory, AI saw a resurgence in the early 2000s with deep learning algorithms and natural language processing or NLP. NLP is used extensively in Gen AI to interpret human communications and to generate content which can be easily understood by humans. Fast advancements in the field led to the release of the first GPT model, aptly named GPT-1, in 2018. Better and more powerful models quickly followed, bringing us to GPT-4 in 2023. This is now creating the loudest buzz in technological circles. Generative AI holds tremendous promise. However, as you can see, it is a relatively new technology, and we are all learning where and how it can be best used. Before we dive into the applications of Gen AI, let's take a quick look at its market potential. Generative AI is projected to grow faster in healthcare than in any other industry, with a compound annual growth rate or CAGR of a staggering 85% through 2027. The total accessible market or TAM is expected to reach 22 billion by that same year. These numbers clearly show the promise of generative AI and the need for its adoption in healthcare industry. What makes Gen AI truly remarkable is its potential impact on all sectors, including healthcare. According to a recent research, generative AI has the capacity to unlock an astonishing $1 trillion in untapped potential within just the healthcare industry. It can do so by automating tedious operational work and bringing years of clinical data to the industry's fingertips. As we explore generative AI further, do keep in mind that this isn't a far off concept, it's already here and it's making waves. In fact, a substantial 68% of respondents in a recent survey are already using some AI tools in their work. And interestingly, 19% within them are using these tools on a daily basis, highlighting the growing importance of AI in the healthcare industry. Now that we have been introduced to generative AI, let us look at some technical aspects. I will try to keep that simple without getting into too much of the details. We'll keep that maybe for some other day. Generative AI looks to replace the task specific models used by traditional AI with models that are trained on a broad set of unlabeled data. Now, what does that mean? As you can see in the diagram, input data may be of a wide variety of types: text, images, videos, speech, or even software code. The data is unstructured and not labeled by humans. The machine ingests this data and learns on its own in an unsupervised or self-supervised manner. These models are called foundation models, or sometimes general purpose AI or GPAI systems. The models can be adapted to a range of tasks such as text synthesis, image manipulation, and audio generation with minimal fine tuning. Foundations models can be standalone systems, or as the name suggests, can serve as the foundation for other downstream applications. GPT-3, DAL-E2, and BERT, some of these you may have heard, are all foundation models, and they have already demonstrated tremendous possibilities. You can ask any question or input a short prompt, and the model spits out an entire essay or an interesting picture. The point to note here is that the model may not have been specifically trained for the topic in question. The strength of a foundation model lies in its ability to also apply this knowledge it has gained from one situation to another. This is similar to how you learn to drive on one specific car, but without too much effort, you are able to drive most other cars or even a truck. The other term that you very often come across when exploring generative AI is a large language model or LLM. This is a type of foundation model that is being widely used today. LLMs are advanced AI models which utilize deep learning techniques specifically tailored for natural language processing tasks. They are known for their ability to achieve a general purpose understanding and generation of human language. The models are trained on vast amounts of textual data encompassing the entire spectrum of human language. In essence, they become language experts, learning from the immense text corpus available on the internet and from other sources. LLMs are responsible for producing text that is coherent, contextually relevant, and often indistinguishable from content created by humans. No wonder they are becoming a major headache for teachers and professors. But used properly, LLMs are the enablers of human like communication, be it for powering chatbots in customer support or providing 24 by 7 medical information. In the context of generative AI, LLMs are the linguistic powerhouses, fueling the creative potential of content generation. As we delve into the realm of generative AI, it's crucial to understand how it differs from traditional AI, or the AI that we have been hearing about in the past decade. Gen AI's primary focus is on generating new content, setting it apart from traditional AI. While traditional AI typically works with structured historical data and predicts outcomes, Gen AI has the unique ability to produce data that wasn't explicitly part of its training dataset. It's like having an AI artist who can create new masterpieces rather than replicating or refining existing ones. One of the fundamental differences lies in their training and learning approaches. Traditional AI mostly works with supervised learning, which uses data labeled by humans to train algorithms that classify that data and predict outcomes. Gen AI, on the other hand, learns from data sets without human annotations. It does this by learning intricate patterns within the data, much like an artist who learns by observing others' artwork and practicing over time, rather than an artist who is formally trained on how to draw. As mentioned before, this type of learning is called unsupervised learning. Gen AI harnesses the power of advanced techniques like generative adversarial networks or GANs and recurrent neural networks or RNNs to create content. Another distinctive feature of Gen AI is its ability to operate effectively with extensive data from a variety of sources, while traditional AI often demands comprehensive data for a specific domain. Gen AI focuses on learning patterns within the data to create new content, This makes it practical for a wide range of applications. What truly sets GenAI apart is its adaptability. It can navigate unfamiliar situations and create new content without extensive retraining. Traditional AI systems, which rely heavily on labeled historical data, may struggle when faced with scenarios outside their established knowledge. Well, now that we have some idea of what Gen AI is and what it does best, let us move on to some of the possible applications of generative AI in the healthcare sector. This is actually the fun part of our journey. As you all know, healthcare generates vast amounts of data, from medical notes and patient records to test results and images. This data is mostly unstructured. We have just learned that GenAI is a master of interpreting and analyzing unstructured data, making it suitable for a variety of different applications. Let us look at a few examples here. Each of these use cases has the potential to bring significant benefits not only to healthcare providers, but also to patients. Gen AI can reduce administrative tasks such as appointment scheduling and documentation. It can also be used to transcribe spoken words into text, make corrections to existing text, or to create detailed clinical notes. This frees up the administrative staff to focus on more important matters. Many routine tasks can also be fully or partially automated. These include medical coding, discharge summaries, and triage. Gen AI can ensure that patients have access to medical information and guidance around the clock. It can also offer invaluable diagnostic assistance. By analyzing patient symptoms and medical histories, Gen AI can tailor treatment plans, medication regimens, and even medical education materials to individual patient needs. We will discuss each of these applications a bit more. Gen AI can streamline various processes starting from a provider's calendar management and patient scheduling to onboarding assistance. It can simplify documentation and create draft pre authorization requests or appeal letters for denied claims. The result? A significant decrease in the time administrative staff have to spend on these tasks. But Gen AI's automation prowess goes beyond that. It can utilize, for example, IT and HR policies to address common questions from hospital employees on these topics. This enhances the overall employee experience as they can quickly and efficiently access the information they need. For all these tasks, relevant material, of course, must be fed to the Gen AI system for it to interpret, analyze, and learn from. As already mentioned, unstructured data can be converted into structured data by Gen AI. This feature can be utilized to provide near real time verification of benefits and finding out the status of claims. Further developments may lead to an accurate calculation of out of pocket costs using the provider's contracted rates and the patient's benefits. An integral part of the healthcare revenue cycle is medical coding. Generative AI can assist in this process, reducing the time and effort required for manual coding. With its ability to learn and adapt, generative AI can reduce the risk of human errors and ensure that healthcare providers receive prompt payment for their services. However, a final review by expert coders may be required to ensure coding accuracy. Gen AI could, with clinician oversight, potentially generate discharge summaries or summaries for referrals. It could also synthesize specialist notes for the primary care physicians. By asking tailored, relevant questions that mimic human conversations, Gen AI enabled emergency rooms can aid in triaging patients. It can also prioritize cases in real time by analyzing the health data collected during the triage process. With the release of platforms like DAL E2 and Midjourney, diffusion generative models have achieved mainstream popularity. These models demonstrate the power of Gen AI to generate breathtaking and often interesting images from simple text prompts. The same technology can be used to accelerate the development of new drugs and reduce the likelihood of adverse side effects. For example, Gen AI is already being used to generate several molecular structures that are potential molecular docking candidates for a drug. These candidates are then examined by the experts to determine the best fit. We have been talking about Gen AI's capability of ingesting a wide variety of data in different media types. By reviewing and analyzing a patient's medical history, current health issues, and lifestyle, Gen AI can formulate personalized treatment recommendations, predict how a disease might progress, and even predict a patient's response to certain treatments. Gen AI is also capable of utilizing data from wearables like smartwatches to offer personalized care recommendations. These recommendations, however, must be reviewed by a physician or clinician before communicating with the patient. Gen AI is meant to help in the process, not replace the expertise of medical professionals. Generative AI can be leveraged to provide on demand access to medical information. By utilizing its advanced contextual search capabilities, Gen AI can provide healthcare professionals and patients with instant access to up to date medical information. Whether it's clarifying a medical term, researching a specific condition or symptom, generative AI ensures that medical knowledge is available 24 by 7. Virtual assistants can be developed through Gen AI. These virtual assistants can interact with patients at any time of day or night. They are like a digital helpline, ready to answer questions and provide information and guidance in a variety of ways. But again, a word of caution here. Such systems should be thoroughly examined by experts to ensure that proper information is being provided to the patients. Additionally, when there is any hint of a critical condition within the patient dialogue, the system must be trained to refrain from providing any further information and refer the patient to a professional. Gen AI also enables personalized health nudges. These can be delivered through various channels like mobile apps or messaging platforms. They are tailored to an individual health need and behaviors, encouraging them to adopt healthier habits and make informed choices. For example, a personalized nudge might remind patients to take their medication, encourage them to engage in physical activity, or provide dietary guidance. This personalized approach fosters patient engagement and enhances the overall health outcomes. Let's look at some other use cases of Gen AI in the healthcare industry. By now, you must have a pretty good idea of the capabilities of Gen AI, so we will just touch upon these without getting into too much details. When it comes to medical imaging, generative AI can play a crucial role in its interpretation. This capability speeds up the physician review process. The healthcare industry relies on a multitude of medical devices, and Gen AI can be trained to predict when these devices may require maintenance or replacement. Generative AI can analyze patient data and medical histories to flag potential issues such as drug interactions or allergy risks. This proactive approach enhances patient safety. While there is no dearth of healthcare data, the data is not always available to researchers and data scientists due to privacy concerns. The only way out is the use of synthetic data. Generative AI, with its creative abilities, can serve that essential purpose, thus preserving patient privacy while advancing medical research and innovation. We have covered a variety of possible applications of generative AI in healthcare, but with any new technology comes its own share of risks. We will discuss some of these here. The more recent a model's version, the better it tends to perform. But that is not always guaranteed. It must be validated. Large language models trained on medical information will similarly have multiple successive versions over short periods of time. But clinical evaluation and certifications take time. So there is always a risk that by the time an evaluation is completed, the model that is being evaluated has already changed substantially with the release of a new version. Regulatory bodies must keep pace with technology to ensure that any solution available to the public is vetted by experts. It is also necessary for generative AI models to incorporate the latest in medical or clinical knowledge to be able to provide the best recommendations. Hence, Gen AI models, especially in healthcare, must be continuously trained with new and updated information. Another major challenge is the trustworthiness of Gen AI generated content. Healthcare professionals must be able to understand what data is being used and how the content is being created in order to build trust. The risks of Gen AI are as varied as the applications. Being aware of these risks will allow you to use Gen AI effectively and safely. Generative AI technology is still evolving and can sometimes generate results that are simply wrong, a phenomenon which is known as hallucinating. Human review of output is therefore essential in any critical application. Patient health data is sensitive and must be handled with extreme care. Gen AI solutions must clarify data ownership, adhere to patient privacy, and look beyond sensitive patient information to the creation and use of synthetic data during the development phase. As with any AI technology, Gen AI also operates as a black box, making it unsettling to some users. To build trust and increase adoption rates, Gen AI solutions must clarify how a given algorithm works and how a specific set of data leads to an outcome. Patients may come to rely too heavily on information generated by Gen AI. Providers and payers must clarify how specific solutions should be used, with clear messaging that AI generated insights are mere recommendations rather than mandates. Because foundation models stem from only a few core technologies, inherent biases in these models might spread through every AI application based on them. These are some of the risks of generative AI. The graph on the right depicts the results of a survey conducted by Bain and Company. Health system executives were asked what they see as the biggest barriers to implementing generative AI in their health system. The top three responses were resource constraints, lack of technical expertise, and regulatory and legal considerations. Now to the most important question: what can this technology do for you? Staff burnout and turnover in healthcare directly affects productivity and operational efficiency. Healthcare organizations are also facing unprecedented financial challenges. Introducing generative AI into healthcare landscape has the potential to address these challenges. Imagine an AI solution available 24 hours a day, 7 days a week, 365 days a year. This support becomes invaluable for healthcare organizations in offloading some of their burden. The capability of chatbots, for example, to simulate human like interactions can be utilized by contact centers for more common level wall interactions. Assisted medical coding or an automated triage can not only significantly reduce manual effort, but also allow your staff to perform higher level patient care functions. As you have seen, Gen AI has the capability to analyze, interpret, summarize, and create documents or other types of media from the knowledge the models have been trained on. You can utilize this capability in myriad different ways in your organization to streamline your processes and improve your bottom line. You, of course, can do it. Generative AI is here to help. With the expertise of our data scientists trained in AI techniques, we at DataCore Healthcare have successfully developed some AI based solutions. We are continuously exploring ways to enhance processes through AI tools while maintaining or improving on the quality. With the help of AI ML algorithms, we are now able to convert paper EOBs to digital data streams like EDI 35. This reduces manual effort, thereby streamlining the payment posting process. DataCore Healthcare has harnessed the strength of AI/ML to work in tandem with a traditional rules-based module to predict the probability and most likely reasons for the denial of claims. Other products that are under development include a coding assistant and a chatbot for interacting with patients. These solutions utilize generative AI technology. At DataCore Healthcare, we are not just service providers, we are strategic allies in your journey towards achieving maximum efficiency through AI. Our process begins with an insightful discussion to understand your unique challenges. Leveraging our expertise, we align our AI solutions to your needs. We then transition to a customized proof of concept that seamlessly integrates into your workflows. The implementation phase is also not performed in isolation, but through active collaboration and close partnership with you. At DataCore Healthcare, we offer more than a solution. We provide a transformative experience, standing with you in the pursuit of elevated patient care and operational excellence. Thank you for considering us as your partner. Thanks again for taking time out of your busy schedule to join us in exploring this newest technology. Sampurna is your point of contact, and her contact information is provided here. If you would like to have a copy of this presentation, please let Sampurna know, and we will be happy to provide you with a copy. We now open the floor for your questions. I will hand over to Sampurna to mediate this segment. Thank you.